Hello class, welcome to the next module of the chapter surface tension, and in this module we are going to learn about excess pressure of bubbles and drop. Now class, consider a drop of radius r. Let Pi be the pressure inside the drop. So if you observe the diagram carefully, I have written Pi, where Pi is nothing but the pressure inside the drop, and let P naught be the pressure outside the drop. Outside as in I am talking about the environment. So Pi is the pressure inside the drop, P naught is the pressure outside the drop. Now class, as of now, I have a drop whose radius is given to me as small r. So if I write the surface area of this drop, I get the total surface area of the drop is nothing but 4 pi r square. Now class, if I were to increase the radius by a small amount delta r, so the bigger drop would be looking something like this, where the total radius is r plus delta r, where r was the original radius and delta r is the increment in radius. So now if I were to write the total area of the drop, it would be 4 pi r square, where this time my radius is r plus delta r. So my new area A2 becomes 4 pi, inside the bracket I have r plus delta r the whole square. So if I solve it further, I get 4 pi r plus delta r the whole square, which is nothing but 4 pi r square plus 2r delta r plus delta r square. Now class, I can write it as 4 pi r square plus 2r delta r. Now class, if you remember, I had incremented the value of r to r plus delta r, where my delta r is a very small number. So I can say that if delta r is small, then I can surely say that delta r square will be even smaller, and hence it can be neglected. So I am neglecting the term delta r square. So I end up with 4 pi inside the bracket. Now I am only left with r square plus 2r delta r. So if I multiply 4 pi inside, I have 4 pi r square plus 8 pi r delta r. Now my original area was 4 pi r square, and my new area is 4 pi r square plus 8 pi r delta r. So that means there is some change in area. So I can say that change in area is equal to A2 minus A1, where A2 is 4 pi r square plus 8 pi r delta r minus A1, which is nothing but 4 pi r square. So my 4 pi r square gets cancelled, and the value of change in area is nothing but 8 pi r delta r. So I am carrying this forward. I have change in area dA as 8 pi r delta r. Now class, in previous module we have learned that surface tension is equal to work done upon change in area. So I can say that T is equal to work done is dW and change in area is dA. So I know that T is equal to dW upon dA. So that therefore I can say that dW is equal to T into dA. Therefore dW is equal to T into dA. Now class, I know that value of dA is nothing but 8 pi r delta r. So I have work done as dW is equal to T into 8 pi r delta r. Till here we have the first part of the derivation. Now let's go for the second part. Now class, I know that value for work done is nothing but force into displacement. As of now, my force is dF and the displacement was dr. So I say that dW is equal to dF into dr. But I know that force is equal to pressure into area. In this question, I am talking about the excess pressure, which was nothing but Pi minus P naught, and the area is 4 pi r square. So I say that dF can be written as Pi minus P naught into 4 pi r square into delta r. So I say that dW is equal to Pi minus P naught 4 pi r square into delta r. So here I have total two equations for dW. The very first equation is T into 8 pi r delta r, and the second equation is Pi minus P naught 4 pi r square delta r. So let us rename. So let's give numbers to this equation. Equation number 1 and 2. Now class, if I compare, on the left hand side I have work done. So if I compare the right hand side, P into 8 pi r delta r is equal to Pi minus P naught 4 pi r square into delta r. Now pi and pi gets cancelled, delta r and delta r also gets cancelled, and one of the r gets cancelled on either of the side. So I end up getting 8 times T is equal to Pi minus P naught into 4 into r. So if I solve it further, I get Pi minus P naught is equal to 8t upon 4r, which is nothing but 2t upon r. So class, this is nothing but the expression for excess pressure inside a drop. Remember, there were total 2 steps. We need to compare the 2 work done. Okay. Now, moving forward, this was the excess pressure inside a drop, which is nothing but 2t by r. Now, let us study what is the excess pressure inside a soap bubble. So I say that if we talk about a bubble, if I were to ask you that how many total number of free surfaces we have inside this bubble, yes, my answer would be 2. I have total 2 free surfaces. That is, one is the outer free surface which is in contact with the air of the atmosphere, and I have one more free surface which is there inside the bubble, which is inside the contact with the air which is inside the bubble. So inside drop, if I talk about, I have only one free surface, and if I talk about bubble, I have 2 free surfaces. So if I have 2 free surfaces, on both the side I have surface tension, so simply it gets multiplied by 2. So I have Pi minus P naught is equal to 2T by R. This was, I am talking about if I talk about a drop. If I talk about a bubble, I have 2 free surfaces, so I multiply this by 2. So I get Pi minus P naught is equal to 4T by R. Remember class, when you talk about a drop, the excess pressure is 2T by R, and when you talk about a bubble, the excess pressure is 4T by R. It simply gets doubled. Why? Because it has 2 free surfaces. So this way you can remember, in bubble you double. So if you talk about drop, it is 2T by R. If you talk about bubble, you double, that is 4T by R. I hope you have understood the module. Thank you.